In today's lesson, we are going to continue working with solving equations. Now, today's equations are going to look a little different because they have variables on both sides. So let's take a look at today's objective. Students will be able to solve equations for a missing value by combining like terms to isolate the variable. So let's review what we already know. We know that we can combine like terms in variable expressions, and this is a key component, a key tool that we need to understand for this objective because we need to move variable expressions around in order to be able to solve the equation. So in this example, we're working with variable expressions that come in the form of a and a cubed. Just like that concept of apples and oranges, we can only combine terms that are alike. So I notice that I have my a's here. Here are my a's. And then I have my a cubes here. And a cubes and a's are two different terms. So we may want to make sure that we are combining terms that are alike. So these two a's together and these two a cubed together. So if I have a positive 6a and a negative 9a, I then have a result of negative 3a. I have a negative 8a cubed and a positive 13a cubed. Since I have more positives than I do negatives, that means my answer is going to be a positive. Then it's going to be 5a cubed. So this expression simplified would look like this: negative 3a plus 5a cubed. From the concept in this particular example is we need to combine like terms. Another key component to being able to solve variable terms in the way that we are looking at equations is to treat variable terms as if they were constants, as if they're regular numbers. So let's take a look at working with constants in this equation. We have 6a plus 2 equals 4. I'm just going to zoom in on the two constants that we have, the positive 2 and the positive 4. And I'm going to treat them as if I have these units that I can add or take away. So if I want to solve for that a, I want to make sure that I get rid of this 2. So I'm going to subtract minus 2 from both sides. So positive 2 and negative 2 is going to give me that 0. This cancels out. And then that 4 minus 2 is going to give me 2. And then the 6a gets brought down. From here, I can just solve for the value of a by using the inverse operation of what's happening to the variable. But what I want to extend in this concept is to look at how can we treat variable terms the same way we treat constants. Let's take a look at an example where we have to work with the variable terms. So in this instance, we have 4b cubed and we have 9b cubed. Now the important thing that we need to understand here is it does not matter where we bring the variable. We can bring the 4b cubed by subtracting both sides by 4b cubed, or we can bring the 9b cubed over to the left. Does not matter. We'll end up with the same result once we apply the OIR method. So let's take a look. If I want to bring over the 4 to the right side, since this is already a positive 4b cubed, I want to do the inverse, which is to subtract. So if I subtract 4b cubed from both sides of the equation, remember I want to keep the equation balanced, it will look like this. 4b cubed minus 4b cubed is going to give me that 0, leaving me with a 2. And then just like I would treat constants, if I have 9 of these units and I'm taking away 4 of these units, then how many of those units do I have left? In this case, it's b cubed. I would have 5 of those units left. 5b cubed. And then from here, we can solve for b by applying the strategies to solve for the variable. So let's take a look at an equation where we need to apply these concepts of combining like terms and adding and subtracting those variable terms the way that we do constants. So in this example, we notice that we have the negative 8x and then the negative 11x, and they're on different sides. So we want to make sure that we are moving around these constants to make sure that we only have the variable on one side of the equation. So the first thing you want to think about is which side you want to move it to. Again, I want to reiterate that it does not matter which side you bring the variable to. So in this case, I want to move the variable to the right. So in order to do that, since I have a negative 8x, I'm going to do the inverse, which is positive 8x. So I'm going to add positive 8x to both sides because I want to keep the equation balanced. So when I do that, a negative 8x and a positive 8x cancels out to 0. A negative 11x plus the 8x is going to give me a negative 3x. And all the constants are going to stay the way they are because we're not working with them quite yet. So once I have negative 44 equals negative 3x plus 16, once I get to this step, it's now just a two-step equation that I can solve using OIR. So let's go ahead and apply our steps in solving. Once I get to my reverse stage, I know that I need to subtract both sides by 16. So then I end up with a negative 60 equals a negative 3x. And then I have to divide both sides by a negative 3. And I should arrive at an answer of x equals negative 60 divided by negative 3 gives us positive 60 divided by 3 is going to give us 20. So x equals positive 20. Let's take a look at a problem together. We have negative 46 minus 2b equals 66 minus 6b. Now the first thing you should notice is that we have variables on both sides of the equation. So in order to get rid of this problem, we need to move the variables to one side. So let's go ahead and move this negative 2b onto the right side by doing the inverse, which is to add 2b. Because it was negative, now you want to invert it with the positive. So add 2b's to both sides, one on the left side of the equal sign, one on the right side of the equal sign. And then we end up with negative 46 equals 66 minus 4b. Now this negative 2b and positive 2b cancels out, so what we're left with is that negative 46. So now we get from here, it's just a matter of OIR. So I'll give you a moment to figure out what the value of b is once you apply OIR and do the inverse operations in reverse order. Alright, if you solve it correctly, you should arrive at an answer of negative 28 equals b. Let's try another problem. Again, in this situation, we have variables on both sides. So for this particular problem, let's try to move it to the left side, just so that you can see it does not matter which side you move it to. You're still going to be able to solve and apply OIR to figure out the value of that variable, that unknown. So in this situation, since we have a negative 3m, we're going to do the inverse, which is to add that 3m. So we're going to add the 3m on both sides. Notice how there's one 3m on the right side of the equal sign, and then there's another 3m on the left side of the equal sign. A negative 9m plus a 3m is going to give us a negative 6m. Keep the constant the same because we're not working with it just quite yet. A negative 3m and a positive 3m is going to cancel out to give us 0, and then we keep that constant of positive 56. From here, we just apply OIR. I'm going to give you a few moments to think about how to solve this problem and find the value of m. Alright, if you solve correctly, you should arrive at an answer of m equals negative 18. Now this time it's all on you. It's your turn to solve this equation all by yourself. Take a look at the two things that we needed to do. We need to apply combining like terms and making sure that the variables are only on one side so that we can apply our OIR tool. So let's go ahead and take a few moments to figure out what the value of h is. And then when you're finished, let's take a look at our challenge problem. What if we had to combine what we learned yesterday about applying the distributive property and then work with today's objective of combining like terms when they appear on both sides? Let's see which scholar can come up with the answer on what x equals in this equation. Good luck.